In today's video, we're going to look at the factors that affect the rate of chemical reactions. So temperature, concentration or pressure, surface area, and the presence or absence of a catalyst. Before we can understand how these factors affect the rate though, we need to cover the theory behind reactions, which is known as collision theory. This states that in order for particles to react, they have to collide with each other with sufficient energy, which we call the activation energy. And if they collide with less energy than this, then nothing will happen. They'll just bounce apart again. So if we were to think about an entire reaction, which will involve tons of particles, then the rate at any particular point is going to depend on two main things. The most obvious is the amount of energy that the particles have. The more energy they have, the more energy they can transfer during the collision, and so the more likely they are to surpass that minimum activation energy. The other important thing is the frequency of the collisions, which just means how often the particles collide with each other. So even though not all collisions are successful, because the particles involved don't always reach activation energy, the more often they collide, the more successful collisions there'll be overall. Now, whenever you think about how these four factors affect the rate of a reaction, you always want to think in terms of how they affect the amount of energy that the particles have and the frequency of the collisions, as increasing either of these will increase the rate of reaction by increasing the number of successful collisions. Let's start with temperature. As the temperature of a reaction increases, the particles gain more energy, which means that they move faster. And because they're moving faster, they'll collide more frequently. They'll also collide with more energy each time, so are more likely to exceed the activation energy. So overall, there will be a higher rate of successful collisions, and thus a higher rate of reaction. Now, concentration and pressure are normally considered as a single factor, because they both refer to how many particles there are per unit of volume. It's just that concentration generally refers to solutions, and pressure refers to gases. When either of these is increased, it means that there'll be more particles per unit of volume, which makes the collisions more frequent, and so increases the rate of reaction. Just like concentration and pressure, a higher surface area will also increase the rate of reaction. For example, if we wanted to react 3 grams of magnesium with an acid, we could use a solid block of magnesium, small chunks of magnesium, or powder. As all of these have the same mass and volume, the powdered form would have the highest surface area to volume ratio, and so it would have a much higher area over which collisions with the other reactants, in this case the acid, could take place, meaning that the frequency of the collisions would be higher, leading to a higher rate of reaction. The last factor that we need to cover is the presence of a catalyst. Catalysts are substances that speed up a reaction without being used up in the reaction themselves. So we don't include them in the reaction equation, as they're not reactants or products. To understand how they work, we can use a reaction profile, which shows the change in the chemical's energy during a reaction. Now, this distance between the reactant's energy level and the very top of the curve is the activation energy, which, remember, is the energy that the collisions have to have before they can react successfully. What a catalyst does is lowers this activation energy by providing an alternative reaction pathway. And this means that there'll be a higher proportion of successful collisions. The word catalyst is actually a pretty broad term, and a whole range of different substances can act as catalysts in different situations. One of the most common sources of catalysts, though, are the transition metals, like cobalt and nickel. And if you do biology, you'll have come across them in the form of enzymes, which are just catalysts made by living organisms. Anyway, that's all for this video, so hope you enjoyed it, and we'll see you next time.